Hello, geometry. This is 12.6. This is the last lesson that's in our textbook, at least. It doesn't have to be the last lesson, and nor will it ever be the last lesson that you ever learn. But it's the last lesson in this textbook, covering binomial distributions, another statistic that you would cover if you would take an elementary stats class or a college stats class like that. Don't be confused by elementary stats. It's not meaning it's from elementary school. It's your most basic college math statistics course. And that's a class that can show up no matter what your major is. So a lot of things that deal with statistics, like if you're in the medical field, or my wife was speech therapy major and she had to take elementary stats, it can show up randomly when you least expect it. So the essential question here is, how can you determine the frequency of each outcome of an event? So what we're starting with here is these are histograms because these are intervaled next to each other. They look like bar graphs, but they're having a coin and they're flipping it. And so they're saying, we're going to flip the coin one time. So this is the number of flips. And they're tracking how many heads can we get. So this right here, these numbers are asking, okay, if I flip a coin, how many could I get 0 heads? Well, yeah, I could get 0 heads one time. Or I could get 1 head one time. It's one or the other. Okay, so you flip a coin. You could get a tail, which means you don't have a head, so you have 0 heads. Or you could get 1 head, and you get the heads, and so you get the 1 there. So they go on, they say, okay, now I'm going to flip it twice. So I have 2 flips. So if I have 2 flips, I could go heads, heads. I could go heads, tails. I could go tails, heads. I could go tails, tails. Okay, those are the 4 options you get here. Notice 1 plus 2 plus 1 is 4. So 0, how many of these have 0 heads? Well, just one of them has 0 heads. Okay? So there's one of them could have 0 heads. So of your sample space, one of them has 0 heads. How many of these have 1 head? Well, that would be the middle 2. They each have 1 head, so there's 2 options, 2 possibilities to get 1 head. And to get 2 heads, there's 1 possibility to get 2 heads. Now they go to 3 flips. So we could go heads, 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 tails, heads, tails, heads. Heads, tails, tails. Okay, there's 1 option there. 3, 6, 7, 8. We could go tails, heads, heads, tails, heads, tails. We got tails, tails, tails. There should be 1 more because we got 3, 6, 7, 8. You probably see it already on the clock here. Tails, heads, heads. Should have done this a little bit better order. Okay, well, we're going to figure it out as we go through here. So how many have 0 heads? How many of these options have 0 heads? Well, that would be this one right here, 0 heads. There's only 1 that has 0 heads. How many of these have 1 head? Well, that would be, this is a 1, and this is a 1. So we're missing tails, tails, heads. That's what we're missing. Okay, so you see 3 options have 1 head. Options with 2 heads would be this one, and this one. So 3 options have 2 heads, and then 1 option has all 3 heads. So that's what they're going through here. They're making the sample space, and they're figuring out, okay, how many of my combinations have 0 heads? So if I do it 4 times, 1 option would have 0 heads. That would be tails, 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 tails. 4 options would have 1 head. 6 options would have 2 heads. 4 options would have 3, and 1 would have 4. You see this curve that's starting to form here. Okay? So question A is, how many ways can 3 heads occur when 5 coins are flipped? So 5 coins are flipped, 1, 2, 3, 4, 5. 3 heads can occur 10 ways. Okay, so out of the total here, we have 10, 20, 30, we have 32 options. We have 32 options, 2 to the 5th power, 32 options. So the probability of getting, what's the probability of getting 3 heads would be 10 out of 32. Okay, 10 out of 32, which reduces down to 0.156. So about 15.6%. Now B and C, this is going to take a lot of time. I'm not going to take this to do right now. Draw a histogram that shows the number of heads that can occur when 6 coins are flipped. So they want us to take these number of heads and go all the way to 6, so n would equal 6. That would be 64 different options. We're not going to take the time to tabulate all that. Okay, so let's get into the vocab, then I'll talk to how we're going to use this. So we have a random variable, okay? And this is just going to be a variable whose value is determined by the outcomes of a probability experiment. Okay, so that's your random variable. So it's how many heads will you get, how many tails will you get, that sort of thing. So a probability distribution, this is a function that gives the probability of each possible value of a random variable. Now here comes the really fancy words, binomial distribution. Okay, binomial means you basically have two options. Bi means two. We're just going to say two things. So binomial distribution, and then binomial experiment. So binomial distribution, this just shows the possibilities let's call that probabilities. Possibilities or probabilities. This is the better one. Of the outcome of a binomial experiment, which is our last term here, binomial experiment. And this is covered right here. Binomial experiment, page 383. We'll go back and finish page 382 in a little bit. Binomial experiment meets the following conditions. Okay, there has to be a set amount of independent trials. Okay, so you're going to be, so you have to know how many times something will happen. Okay, each trial has only two possible outcomes, success and failure. Okay, the probability of success is the same for each trial. This probability is denoted by P. So the probability is going to be P, the probability of success. Okay, so if we want the heads on a coin flip, the probability of success would be 50%. The probability of failure is 1 minus P. So the probability exactly K successes in N trials, there's your N, is this formula right there, which is going to work what we're going to look at. Okay? So there has to be a set amount of times that you're going to do something. You can either get something right or you can get something wrong. So success and failure, there's no halfway with the binomial experiment. So binomial, there's your two choices, success and failure. Your probability of success is P. The probability of failure is 1 minus P. Okay? So we're going to come back and look at that. Let's go here. This is a probability distribution, example of it. It's a function that gives the probability of each possible value. So here's your probability distribution. If you're rolling a 6-sided die, the probability of rolling a 1 would be 1/6. Probability of rolling a 2 would be 1/6. 3 would be 1/6. 4 would be 1/6. 5 would be 1/6. 6 would be 1/6. Okay? So if they want us to make a histogram of this, Histogram has bars. 2, 3, 4, 5, 6. So this is our 1, 2, 3, 5, 6. All of them have a probability of 1/6. So if this is 100%, 1, 2, 3, 4, 5, 6. So this would be 1/2. This would be 1/6 right there. Sorry, there you go. So the probability of 1 would be 1/6. Okay, so this would, a histogram shows the probability of each variable value. Let's put it that way. Okay, so 1, the probability of rolling a 1 would be 1/6. The probability of rolling a 2 would be 1/6. The probability of rolling a 3 would be 1/6, and so forth and so on. Okay. All different shapes in there. Okay. So that's what we're kind of looking at back on this page as well. These are basically your histograms showing you, okay, what's the probability of getting 2s? Well, there's 10. That'd be 10 out of 32 in this case. Okay. They didn't put the percentages there, but the same idea. Okay. So let's look at this formula right here. And we're going to break it up into 3 parts. We first have this. This is a combination. So this is going to be a combination, an N of N trials, and K is how many successes. And they're going to give you those. So the combination of N trials given K successes. So let's look at this first one. We'll talk about this first part of the equation. There's 3 parts here. A coin is flipped 10 times. Okay, that is going to be your N. So N is 10, because we're doing something 10 times. That's how many trials we have. What is the probability of getting 8 heads? Okay, 8 is going to be our success value, so this is our K. They want to know the probability of getting 8 heads. So N is 10, and 8 is going to be K. So the first part, we want the probability of 8 heads, and it's going to start as we have to figure out what is 10 choose 8. And we can use the formula from the last lesson, or I'm going to be using the calculator. Okay, so let's talk about this next part here, P to the K. Remember, P is your probability of success. And the K is the number of successes you want. So it's the probability of success raised to the number of success that you want. So this is going to be multiplied by our probability of success. If we're flipping a coin, the probability of getting a heads is 1/2. So that's a probability of 0.5. We want to do that 8 times. Okay, 0.5 to the 8 times. And finally, this last part, let's go black. This right here, this is the probability of failure to the trials minus successes. So it's basically how many you have left. So if you have a 50% chance of being successful, that means we're going to have a 50% chance of being unsuccessful. Okay? So it's the probability of everything else. And if we want 8 heads, that means we want 2 tails. So we have how many combinations we have of 8 for 8 heads. It's going to figure that out for us. 0.5 to the 8 power, so the probability of success to how many successes you want, times the probability of failure to how many failures you want. You want failure, this is how many failures you want, this is how many successes you want. Okay, so on the calculator, I'm going to go 10, choose 8, times 0.5 raised to the 8th, times 0.5 squared. Okay. This is what the calculator looks like. 10 choose 8 times all that. And that's going to give me a 4.4% chance. 0.0439. So there's a 4.4% chance that I would get 8 heads. out of that. Okay, not very good. Look at this example. A multiple choice test has 20 questions. Ding, 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 ding. There's your N. And each question has 4 options. You need to get 14 correct to pass. What is the probability if you guess on each question? Okay. So if you have 4 options, the probability of success is going to be 1/4 of 0.25. The probability of failure, because remember, on a binomial experiment, everything has to be either success or failure, that's going to be 3/4, or 0.75. So we have 20 as our N. We're going to have 20 trials. We want to get 14 correct. That's our K value. So I have 20 choose 14 times, okay, the probability, let's go back up here, the probability of success raised to how many successes you want. Okay, so that is the probability of success is 0.25, and I want to get that right 14 times. And then the probability of failure is 0.75, and I can do that 6 times. 14 plus 6 has to equal to 20. Okay, so 20 choose 14, just so we can see this, times 0.25 raised to the 14th power, okay, hit the right arrow to go back down, times 0.75 raised to the 6th power. Okay, not very good. What this is, it's not 2.56. Notice the scientific notation, that's times 10 to the negative 5th. So that is going to be 0.12345 Okay, so that would be about move it 2 to the right to get percentage, 0.0026% of getting passing if you just randomly guess on each one. Okay, normally it doesn't play out that way because you can sometimes make an educated guess or reduce one of the options. Okay, page 383. I did a lot of setup here. You can pause and kind of get some of this set up, but make a table and draw a histogram showing the probability distribution for the random variable P. If P equals the sum, I changed that from the words in the textbook or in the journal. When 2 6-sided dice are rolling, the product gave me lots of numbers, is going to be even worse. Okay, so what I have here is I have a table. This is my sample space. I have 1 through 6 going down here, 1 through 6. This is what we can roll. If I roll a 1 and a 1, 1 plus 1 is 2. 1 plus 2 is 3, 1 plus 3 is 4. Okay, 4 plus 3 is 7. So these are the sums. So here, the probability of each sum. So a 2, I have 36 options. The probability of getting a 2, well, 2 just shows up once. So that'd be 1 out of 36, which is about 0.027. 0.028. Okay. The probability of 3. 3 is 2 out of 36, which would be 0.056. Leave enough room in here. 4s. Okay, I'm going to cross these off as I use them. 4s, there are 3 out of 36. That's 0.083. 5s, okay, there's the 4s. You notice how these are all on the diagonal. 5s are 1, 2, 3, 4. 4 out of 36. That should be 1/9, so 0.1 repeating. 0.11, see how it's going up. 6 out of 36, it's 1/6. So, sorry. 6 is 1, 2, 3, 4, 5. 5 out of 36. 0.14. 7 out of 36, okay, 7s, there are 1, 2, 3, 4, 5, 6 7s. And that would be 0.17, about there. 8, and now we start going down, 1, 2, there's 5 out of 36. So that would be 0.14. 9 would be 4 out of 36, so that's 0.11. 10 would be, there's 3 out of 36. That's 0.083. I'm getting these from just the earlier numbers here. 11 would be 2 out of 36, which is 0.056, and 12 would be 1 out of 36, which is 0.028. Okay, So this would be your probability distribution, that chart right there. Okay, these are your probabilities of getting these numbers. Okay, so probability distribution is just this chart. The histogram, we got 1, 2, 3, 4, not 2, sorry, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so those are the different values that we have here with our probability distribution. So we're just going to draw each one. So a 2 was 0.028. That would be right there. 3 was 0.056. That'd be a little bit higher right there. 4 was 0.083. So let me get too far off here. Try to keep that parallel. Get screwed over a little bit. Got some work to do. Okay, so there's 4. 5 was 0.11. There's 5. 6 was 0.14. So you notice I'm using those probabilities. I'm not using the total number. I'm using the probabilities to make this histogram. 7 was 0.14. 7.17. So which number is most likely to be rolled? Okay. If you're a Settlers of Catan player, you'll notice that there are a lot more 5, 6, and 7s. Okay, those are the more commonly rolled ones. Okay, 8, we start going back down. Let's speed this up a little bit. It's 8, 9, and it's symmetric. This is a good binomial distribution. Okay, so there's your histogram, there's your probability distribution, and your histogram. Okay, so use the probability distribution to determine A, the number that is most likely to be spun on the spinner, and then B, the probability of spinning a perfect square. Okay, so here they've already given us a probability distribution, so here's your probability and the number on a spinner. So this means there is not equal opportunity for each number. So A, the number that is most likely to be spun would be 4, which means there are the most 4s on there. Okay, there's more 4s than any other number on there, or it's the biggest area. Okay, so 4 is the number most likely to be spun. For B, the probability of perfect square, that'd be either a 1 or a 4. So the probability of a 1 is 0.2. The probability of 4 is 0.4. We add those together and we get 0.6. So there's a 60% chance you'd roll a perfect square, a 1 or a 4. Okay, calculate the probability of flipping a coin 20 times, so N is going to be 20, and getting 19 heads. So we want 19 heads. So this is going to come back to our formula that we had over here. So the probability of 19 heads, so similar to this one that I did right here. So our probability of success, so the probability of 19 heads is going to be 20 choose 19. So how many combinations out of 20 would have 19 heads? Times the probability of success. So the probability of success is 50%. Okay, so the probability of success is 50%. The probability of failure is 1 minus 0.5, which is also 50%. So we want heads 19 times. So the probability of success times how many you want, times the probability of failure times how many you want of those, which would just be 1, because 19 plus 1 gives us the 20. This is going to be another scientific notation number. So we have 20, and we want to choose 19. How many sets of 19 of the same thing there? Times 0.5 raised to the 19th power times 0.5 raised to the first. Now you don't have to put the 1 there, you can just put 0.5 again. Okay, this is 1.9 times 10 to the negative 5th. So 1.9 times 10 to the negative 5th, that'd be 0.1234419, be 0.0019%. Not very good. Okay, number 4 is going to take a little bit of time, but this is our last one. According to a survey, 78% of women in a city watch professional football. You ask 4 randomly chosen women from the city whether they watch professional football. Draw a histogram of the binomial distribution for your survey. So we don't know the probability, well, all we know is 78%. That's the probability of success, okay? You're asking 4 random, so this is going to be how many instances you have. So n is going to be 4. Now the thing we don't have is k. K could be 0, 1, 2, 3, or 4. It could be any one of those. So they want a histogram of the binomial distribution for the survey. This is P. Okay? So the probability of success that we have here is 78%. The probability of failure is going to be 22%. 100 minus 78, basically. So we have to figure out the probabilities for each of these Ks. So we need the probability for each K. So let's say we want the probability of 0. That would be, say we're using this formula up again here. So we have 4 choose 0 times 0.78 to the 0 power times 0.22 to the 4th power. Okay? Because of the 4, what's the probability that none of them would watch professional football? So we want 0 successes, we want 4 failures. Okay? So we have, clear that up, 4 choose 0 times 0.78 raised to the 0 power times 0.22 raised to the 4th power. So what we get here is 2.3 times 10 to the negative 3rd, which is 0.0023. Okay, if you're rounding 2 decimal places, that's essentially 0. Okay, we're going to just call that 0. So you really have not any chance at all. Very, very slim chance. Okay, 0.0023, we'll call it that. What's the probability of 1 success? So probability of getting 1 of the 4 that watch professional football. So we have 4, and we're choosing 1. Now we want 0.78 to the 1st power, so because we want 1 success and we want 3 failures. Okay, so I want 3 failures, I want 1 success, and we're going to choose 1. 0.03. Now we're going to do it for 4. So probability of 2. Let's change another color so this doesn't get too tight in here. So that's 4 choose 2 times 0.78. Now we want 2 successes and we want 2 failures. So 2 failures, 2 successes, and we want combinations of 2. 0.17. We'll call that 0.18. Probability of 3 would be 4 choose 3 times 0.78 to the 3rd power times 0.22 to the 1st power. That's to the 1st. That's to the 3rd. And we want combinations of 3. 0.41. Okay, the final one is probability of 4. What's the probability that all 4 would watch professional football? That's 0.78 to the 4th power times 0.22 to the 0 power. So 0, 4, 4. And it dropped a little bit, 0.37. Okay, so there's that. They want the histogram. So we have 0, 1, 2, 3, and 4. And our y-axis, our probabilities go from 0 pretty much up to 0.41. So we'll call this 0.4, 0.2. So 0 was as close to that as we can. little bit. So the probability of getting 0 is not very likely at all. Even probability of just having 1 was 0.3, so that'd just be a little bit higher there. The probability that 2 would watch professional football was 0.18, so now that's right below the 0.2 range. Probability of 3 was 0.41, that shot up there. And the probability of 4 was 0.37, dropped a little bit. Okay, what is the most likely outcome of your survey? So most likely would be the highest probability. So the highest probability is 3 selected would watch professional football. It kind of makes sense with our percentage. 78% is pretty much 75%, 3 out of 4. So since you're selecting 4 of them, that makes sense. What is the probability that at most 1 woman watches professional football? Well, that would be 0.03 plus 0.0023. That'd be 0.0323. So about a 3.2% chance that at most 1 of them would watch football. Oh, there you go. Okay, so there's very quick, no, it took a while, but that is still quick, crash course in binomial distributions. I hope that made sense to you. When we're together, we can definitely ask questions and go through some things together here, but try to do some of these questions on your own and see what you can figure out.